Hello everybody, welcome back to today's tutorial. Today's video we're going to be making a simple dice roller. Now this is going to be a simple system that you can expand upon in your own personal projects and add features that you may desire, but in today's video we're only going to cover the basics. So in this project we'll have UI that will display what values the dice you roll. We'll have a dice roller that'll actually take some form of input. In this case it's going to be user input from the keyboard, and then we're going to have dice that are automatically going to roll, track their own rolling velocity, and score themselves once they stop. So here's what that's going to look like. I'm going to press the space bar. It's going to roll some dice for us. We're going to see where they land, and our UI will update with their scores. Now these dice can be re-rolled, and we can roll as many dice as we want, but in this case we're just going to roll 2. We're going to start off by creating our dice prefab. Now to do this you can use any die model that you find online or from the asset store. Regardless, you're going to want to pull that into Unity and get it in a prefab. You're going to want to make sure it's got a box collider on it that matches the size of your die. And then we're going to go ahead and add a rigid body component. Now this rigid body will allow us to actually throw the dice and manipulate it so it can actually roll. And to help us do that, what we're going to want to do is go to our interpolation and set it to interpolate. And then we're going to go down here to collision detection, and we're going to go ahead and set that to continuous. To help our dice roll a little bit better, what we're going to do is we're going to give it a physics material. So right click, create physics material, and you can call this whatever you want. I'm going to call it dice material. And we can change some of these values in here on the friction, but I got good results just changing the bounciness. I'm going to set this to 0.5. What this is going to do is make it so when our dice hits the ground or your board or whatever sort of surface that you're rolling your dice on, it's going to bounce a little bit, kind of like they would in real life, but not bounce too much that they never stop rolling. So take that physics material and just throw it on your box collider right there. And now we can start getting into the script. Right click, go to create, scripting. We're going to create a new mono behavior script, and let's just call this dice. This is the script that's actually going to go on the dice themselves. When your script opens up, we're going to start off by getting a few references to some objects and set up a few variables that we're going to use here in a little bit. The first one we're going to do is going to be a private rigid body. And this is going to be the rigid body that's actually on the key. We're going to use this to track its velocity. Next, we're going to set up 2 booleans. The first one is going to be has stopped rolling. This is going to let us know if the die has stopped rolling and if we need to check what value is up. We're going to default this to false. That way, as soon as the die gets instantiated, it's not already set to true because it clearly hasn't stopped rolling it. And then we're going to do another boolean, and this one is going to be has throw delay finished. What this is going to do is it's going to let us know if the dice has just been thrown, and we're going to actually wait a little bit before we start checking if the dice has stopped rolling. That way we don't encounter a slight bug where the velocity is initialized at 0, and so the game thinks that, oh, your dice has stopped rolling, when it really hasn't just applied the force yet. So this is going to help us prevent that bug later down the line. Now we're going to go through here, delete these comments, we don't need them, and we're actually going to add an awake method here. And in our awake method, we are going to get the rigid body component, and we're going to cache that for later use. We actually do not need a start method, so you can get rid of that completely. And in our update method, this is where we're going to put some logic in to see if the dice needs to check if it's done rolling or not. We can do that with 2 simple if statements. We're going to start off with if not has throw delay finished, and if our throw delay hasn't finished, we're just going to return. If I can type. The second if statement is going to be used to check if the dice has actually stopped rolling. And now how we're going to do that is we're going to set up a second if statement, and we're going to say if it has not stopped rolling, and our rigid body dot linear velocity dot square magnitude is equal to 0. And what this is going to do is tell us if the rigid body is still detecting that it's rolling or not. And if it's not rolling, it'll execute this code. So we can set has stopped rolling to true. Now we're going to add a new method in here called get side up. And we haven't made this method yet, but we're going to create it here in a second. So we can go ahead and generate that. And what this is going to do is this is going to be where we actually tell our dice which side is up. This part of the tutorial is going to be a little messy and dependent on which model dice you used. We're going to create an array of vector 3s, and these are going to be specific towards the orientation on your die. So this step may differ slightly for you, but you'll just have to change which sides are which. So I'm going to create a new vector 3 array, and we're going to call this sides. And that's going to be a new vector 3, and we are actually going to pass this in the constructor. And what we're going to do is we're going to use the transform and get the up, forward, and right normalized vectors, and we're going to use those to figure out which side of the cube is which. So I'm going to start with transform dot forward dot normalized, and then we're going to add a comma, transform dot right normalized, comma, transform dot up normalized. And then what you're going to do is we can just copy and paste these three, and we're going to have the negative values of those, or the inverse of these vectors, and that's going to get us the left, the down, and the back. Make sure you get rid of this comma at the end, and we want to add a semicolon right here. So now what you can do is if we just drag our cube into the scene here, we can come focus up on it, and based off of how these arrows point, I can tell that based off of my z-axis, my number 1 side is my forward, my number 2 side is my up, and my number 4 side is my right side. And using these values, we can say, okay, maybe I want to rearrange these in a different way. Now, I've already done this, so I'm going to just copy and paste that in here. But to make this simple for me, I've gone through and I've matched each side to a little comment in the code that says which number is which side. Now, once you've done that, we can get into the actually calculating how we're going to tell which side is up. Before we add our logic that's going to calculate which side is up, we need to add 2 more things up here at the top. We're going to add an integer that's going to track which dice index this dice actually is. So we're going to go private integer, and we're going to call that dice index. We're going to default that to -1. Dice index. We're going to default that to -1, and this value will be assigned by the dice thrower so that this die knows which out of the handful of dice it itself actually is. And we're also going to add a unity action. So public static unity action, and we're going to pass 2 variables through this. We're going to pass an integer and another int, and we're going to call this on dice result. Now down here we can actually start building our logic. We're going to start with a for loop, and we're going to iterate over all of these sides in our array. So we're going to check every single side on this dice. The way we're going to do that is we're going to use an if statement that checks the dot product between the vectors on our dice and our vectors in the world. And what that'll do is if we fall within a certain tolerance, we will know which side is up. Now, speaking of tolerance, we need to go back up, and I'm going to add this as a serialized field. So it's already up here, and I want it serialized so that we can assign this later in the inspector if need be. Now we're going to go into our if statement. So if our vector3 dot product, and we're going to check our sides I against our world vector3 dot up, and we're going to get that by doing vector3 dot up. Now this will return the vector3 for the world and not our object. So our first value is the object's vector, the second value is the world's vector. And we just want to make sure that that is greater than our tolerance. Now, if that falls true, and it is close enough that our tolerance threshold is met, we're going to invoke our onDice result. And we're going to invoke. And when we invoke this, we are going to pass two things. We're going to pass the dice index, and we're also going to pass our I plus 1. So what this is going to do is this is going to tell us which dice it is, and this value is our result. Now, the reason I set up our vector array like this is so that we can tell the side of the cube based off of which index this is in. So side 1 is in index position 0. We take that and we add 1. We know our side value is 1. If it's 6, our index position is 5. Our I value plus 1, that's 6. So when we invoke this, we say this dice number had this side up. We're going to go down here and we're going to add a debug.log. And we're just going to say if none of these sides met our criteria, we're going to say no sides within tolerance. And what that's going to do is that's going to tell us if the cube is positioned perfectly at a 45-degree angle or not. If it is, we can add some logic in this thing's place to either re-roll the dice or do something else, maybe add another little force to bump it a little bit. But for the sake of this course, I'm just going to leave this debug.log, and then you can fit that result to your project should you need it. To get our dice to actually roll, we're going to add two more methods. We're going to start out with an internal void roll dice. And this is going to be what actually applies the force to our dice. Now to do that, we're going to want to take in a few methods or values. So we're going to do a float, and we're going to get our throw force. Next, we're going to get another float, and this one is going to be our roll force. And last, we're going to get an integer, and this is going to be the dice index. Now, in this method, we're going to start off by setting our dice index equal to the past dice index. This is going to come from the dice roller. Dice roller is going to call this roll dice function, and it's going to pass all these values, and this is going to tell the dice what its index is. We're going to vary our dice throws a little bit by creating a random variance for every throw. This is going to help break up the physics a little bit so that the dice don't roll the same way every time and you don't get the same numbers every time. We're going to do that by creating a new float, random variance, and we're going to assign that to a random.range, and we're going to set this from a -1 float to a +1 float. And we want the floats so that we can get a wider range of values, whereas if we didn't have those f's in there, it would just return integers, and that's not what we want. So now we're going to go to our rigid body dot add force, and we're going to add our transform.forward. we are going to multiply that. We're going to multiply that by our throw force and our random variance. Now we're going to set the force mode to impulse, and this is going to get our dice moving forward with a little bit of variation. Now our dice goes forward, but it doesn't roll unless it hits something. We can fix that. What we're going to do is we're going to create a random roll on every dice throw. At least random rotation roll on every dice throw. So we're going to do that by doing 3 floats, and we're going to call this roll X, and that's going to be a random dot range, except this one we want 0 to 1 as floats. And you can just copy and paste this 3 times, and we're going to change this one to Y, and we're going to change this one to Z. So every time you roll, we're going to get a random roll X, Y, and Z value. So we can go to our rigid body dot add torque, and we're going to do a new vector 3, and we're going to set up this vector 3 as our roll X, roll Y, roll Z, and we're going to multiply that by our roll force plus our random variation. Now what this is going to do is this is going to throw our dice forward, and then this is going to rotate our dice randomly. And after that, now that our dice have been thrown, we want to start a coroutine, and we're going to call this coroutine throw delay. Now we haven't made this method yet, so we're going to have to do that real quick. We can just do a private enumerator, and we're going to call it throw delay. Just like that. And now in here, we're going to yield return. New wait for seconds, and I'm just going to wait for 1 second so that our rigid body has time to get the forces applied, and then we can start checking if the dice is done. And once the 1 second is up, we're going to set has throw delay finished to true. That's going to let our update method up here know, hey, the throw delay has finished. Now you can start checking if the dice has stopped rolling. Back in Unity, we can get our scene set up. I've just got a little box here. It's just made out of a bunch of cubes that I've put together, floors and walls. Biggest thing is you just have a surface with a box collider that our dice can bounce off of. What we're going to do next is we're going to create an empty game object, and we can call this the dice roller. This is going to be what actually rolls your dice. Well, looks like I already have 2 of them, so I'll delete one. This is what's actually going to roll your dice, and we can go ahead and create a new mono behavior, and we're just going to call this dice roller. Go ahead and open that up in Visual Studio. Alright, now we are going to get rid of most of this, and we're going to declare some variables. We're going to start off by getting a reference to our dice prefab. So we're going to do a public dice, and we're going to call this dice prefab. This is public so that we can set it in the inspector really easily. We could also do a private serialized field, but in this case, I'll just leave it as public. We're also going to do a public integer amount of dice to throw. And I'm going to default this to 2. We're going to add a public float, and this will be our throw force. I'm going to default this to 5. And one last one, we're going to do a public roll force. I'm going to default this to, let's say, 10. Now, all of these variables you can technically have as private, but I'm going to keep them as public. And if you were doing this in your own game, what I would do is have your amount of dice variable be tied to different game systems. So depending on what game that was, if you had a special card game that you had to roll different amounts of dice every turn, you could just externally assign this variable. But for now, we're going to keep it public to symbolize that, hey, you can change this later if you want. And these two are going to be public so that we can see them in the inspector, and we can tweak those values as we see fit. Or if you wanted to have some gameplay mechanic that wanted to change these, you'd also be able to assign those externally. Now we're going to add one more Unity action. And we're going to call this, actually we're going to pass it an integer, and we're going to call this on dice roll. Now what this is going to do is later, once we throw our dice and we're working with UI, this is going to tell our UI, hey, we just rolled the dice, clear yourself. But we will get to that here in a little bit. First off, we're going to detect input. We're going to do this super simple in our update method. We're going to do an if statement, input dot get key down, and we're going to do key code dot space. And this is going to say, hey, the user has pressed the space bar, do what we're about to do. We're going to do a start coroutine, and we're going to call this coroutine roll dice. So guess what we're about to do? Down here, underneath our update, we're going to go to private, enumerator, and we're going to call this roll dice. In here, we're going to listen, or we're going to invoke our dice roll Unity action, so on dice roll. And we are going to invoke, and we will pass our amount of dice. This is going to tell the UI how many dice we just rolled, so it knows how many UI elements to adjust. But like I said, we'll get to there later. This first if we're going to do is to see if you have actually assigned the dice in the inspector. So we're going to do an if dice to, or dice prefab is equal to null. We are going to yield break. This is just going to get us out of our loop, say, hey, you need to assign your dice. Now, if you have assigned it, we're going to do a for loop. We're going to go integer I for less than the amount of dice to throw, and we're going to increment it. We're going to go dice equals instantiate, and we're going to do dice prefab at the transform position and at the transform rotation. Now we're going to add a list up here. We're going to do a private list dice, and we're going to call this spawn dice. This is going to help us keep track of all the dice that we've spawned. So down here we're going to do spawn dice, and we're going to add the dice dot game object. Oh, our list up here needs to be of type game object. Now we're going to take that dice that we just spawned and we're going to dot roll dice. Now when we roll the dice, we want to pass the throw force, the roll force, and our I. That I will tell the die which number out of the amount of dice to throw that it actually is. And from here, yield return null, just so that all of our code paths return a value. Before we jump back into Unity, I actually noticed two things that I forgot. So on our private list where we're keeping track of the spawn dice, we need to actually instantiate that list. So we're going to say a new list of type game object. Also on here, when we roll the dice, we just spawn the dice over and over and over, but we don't have anything that gets rid of the dice that have already spawned. So underneath this if statement, I'm going to give a little bit of space, and we're going to do a simple for each loop. So for each var die in spawned dice, we are going to destroy the die. Now that we're back in the Unity editor, we can go to our dice roller over here and actually add the dice roller script to it. Now this dice prefab is where we're going to want to add our dice. So come down to your dice prefab and we're going to put that dice script on it. Come on. There we go. And this tolerance value, I actually don't want it set to 0.99. What I'm going to do is I'm going to set it to 0.719. And the reason I want this value specifically is the way that the dot product works is it uses the cosine of the angle between our two vectors. And I want any angle that is less than 44 degrees apart. And the cosine of 44 is 0.719. So by putting this value in here, it'll tell us which vector on the die is less than 44 degrees away from our world vector up. So we can come back to our dice roller and we can throw our dice in there. And we should, if I move this more central on our camera, we should be able to hit play and see our dice roll. When you look at that, you can see them coming down from the heavens. And then if we roll again, there we go. And you see every time I push space, it re-rolls our die. All right. Now let's take a look at getting some UI implemented with this so we can get the results of the dice that we rolled. For our UI, I've created a fairly simple canvas, and it looks a little bit like this. So I just have our roll results up here in a panel, and then I have the container, and then I made a simple prefab. All it has in it is a text component, and we're gonna actually change this text component on what it has in it. And so we're gonna create a new script down here, and we're gonna call it the UI manager. Go ahead and open that up. All right, in here we're gonna need three things. And I'm gonna serialize all of these so that they stay private, but I can still assign them in the inspector. We're gonna need a serialize field, private, game object, and this is gonna be our result container. We're gonna need another serialize field, and this one is going to be a private game object, and this is going to be our text prefab. Last, we're going to need a new serialized field, and this is going to be a private list, and this is going to be a type game object. And this is going to be results text boxes. And that's going to be a new game object list. So on our enable, we want to subscribe to our listener methods. The two things that we need to listen for is our dice roller for when it rolls the dice so that we can clear the UI, and our dice, once they settle and get the result, we need to display what those results are. So we're going to do dice roller dot on dice roll, and we're going to subscribe to a listener, and we're going to create a method called set dice UI. And then down here we're going to do dice dot on dice results, and we're going to listen to set text. Now it's important that we come in and we also unsubscribe from these methods on disable. So on disable, we unsubscribe from those. Now let's make our methods. We're going to start with setting the dice UI. And next we're going to add set text. Now on our set dice UI, we need to take in an integer, and this is going to be the number of dice rolled. And on our set text, we need to take in an integer dice index and an integer dice result. There we go. Now our subscribers are happy. This set dice UI is going to be used to help keep my UI fluid. The type of game that I plan on making has different amounts of dice rolls for each turn, so I want to be able to dynamically create and remove UI as needed based off of how many dice the player has to roll that turn. The way we're going to do that is with a for each loop. And we're going to do for each text box in result text boxes, and we're just simply going to destroy it. Destroy text box. So this is going to get rid of any existing UI text boxes that may currently be present, and we're going to take our result text boxes and we're just going to clear that. This is going to get rid of any broken object references that were created by the for each loop, destroying the text box items. And now we're going to do a for loop, and we're going to iterate over the amount of dice rolled. So for each dice that's rolled, we want to add it to our list and instantiate a new item. Now we can do this all at once by taking our result text boxes dot add, and in our add method we can instantiate our text prefab. So when we instantiate our text prefab, we're going to instantiate it as a child of our result container dot transform. So that way it's a child, and we can use things like horizontal layout groups to automatically style our UI. Next, we're going to go down to set the text. So this is going to happen when the dice finishes rolling. It's going to broadcast out, hey, this is my value. Our UI is going to pick that up, and we want to know which dice index got which result. So the way we're going to do that is result text boxes, and we're going to go to the dice index dot get component, and we want to get the TMP text component of this so that we can set the text in there. TMP text dot text, so we can edit the text value. And we're going to set that to dice. So dice index, so we know which number dice it is. Rolled a dice result. So what this will do, it'll update the UI with this index and this result. So let's jump back into Unity and see how that looks when we put it together. Back in Unity, I'm going to come to my parent panel object, and I'm going to drag and drop my UI manager on here. And now I can take my result container that I have here, and I can drop it in there. And then that text prefab I made, I can just throw it in there. So now let's do a quick test and see if it tracks our results. There we go. We get 2 dice rolled. When they settle, we can see what they roll. They settle, we can see what they roll. Now, let's say that I don't think my dice are being thrown hard enough. We can bump these values up. Let's say I want to roll 5 dice. Everything will adjust automatically, and now our dice explode all over the place and they roll. And once they all settle, all of our dice populate, and I can re-roll them again. Awesome. Thank you everyone so much for watching. I hope this information was useful, and maybe you can expand upon it in your own personal projects. If you have any questions, feel free to leave them down in the comments below.